So when we have one simple query, which is the kind of data that you want to get from the database into Hadoop. The second thing is the bounding query, which is how you want that, what is the range of the column by which you want the query to be split. So let's say, like in my previous example, I had mentioned a query from the employee and the designation tables, where you're joining between the two tables and you're getting the data. So that is going to, let's say, result in, let's say, 10,000 records. Okay. But what we want is that we don't want to have, all the records coming in through one single query. What we want is that we want to split the query across various slaves on our Hadoop cluster. So what we say is that we want the minimum ID and the maximum ID, which gives us the range of the query splitting. So let's say you get somewhere like, and then you also specify the actual number of mappers that you wish to use. So the database resources are obviously, you want to conserve them. So there is only a fixed number of connections that you want to have with the database. So this actual numbers of mappers to use is actually going to, control how many connections parallelly you are going to have with the database. So that is actually a limiting factor that you have. Okay, so let's say I say that, I want to just use 10 mappers in one row. And I have a min ID and a max ID from employee, which is, let's say, 100 to 20,000, let's say. Okay, so what we are going to do is, and what we say is, there's something called a split column, which is the employee ID. So what we are saying is that between 10 and 10,000 employees are to be split across 10 mappers. So the previous query will actually, have bounding clauses. Wherever there was AND conditions, you will have something like where employee.id is greater than 10 and less than 1,000, is greater than 1,001 and less than 2,000, and things like that. So basically you split across your query across various mappers and you get only relevant records and you write them down. So that is how it works. And you actually don't have to, as a user of VO, you don't have to actually just write anything. All this is specified in the configuration file. And there would be other parameters to use, things like the JDBC connection parameters. So again, as I talked about, once it gets the data from the database, there is a format choice that you can choose. Again, this is configurable. You can have something like delimited, and you can choose whatever delimiter you want. You can serialize it into Avro. The reason behind choosing Avro is that you can have a generic purpose schema to define your objects. It is very compact, and you can actually define a generic purpose rules kind of a language over Avro, which it doesn't exist as of now, but it's very easy to write something like that. And if you want, you have your own framework, you have your own format, you can just intercept the data and get it, convert it into the format of your choice. So once we've got the data into Hadoop and we've done our mappers, we've done whatever analytics we wanted to do, we've extracted the meaningful information, and let's say we want to dump it out to a database so that users from the website or our business users can actually check whatever churning we have done. So this is where Hadoop out actually comes into picture, where you're pushing all your processing, eventual processing, back to the database. So currently, the support in HEO for Hadoop out is limited to MySQL. It uses MySQL extensions, and instead of using traditional inserts, what it does is it uses load data local int file for faster processing. So it actually takes over, it reads over the entire file and passes it in one go to the database. So this is how it again, for the configuration, it is pretty trivial. You just have to give the name of the table. You specify what is the format of the file that you want to export out to the database, and you give the connection parameters. So, key next steps actually. So, I think the main, like HEO's come so far, we've had 2 releases, we've seen a very good response of people. There's been a lot of interest and a lot of features being requested. So the next big thing is, like, I am actually the sole contributor to HEO, and the next thing that I would love to see happening is, that we have more contributions coming in. More contributions, not necessarily in terms of, just coding, but just feature requests or, documentation updates, mailing ideas, anything that, people would like to see in HEO, or they feel that it's not working up to their expectations. So we just want to, build a community of users, of developers who want to use it, who want to work with it, or maybe support it. So there are other critical technical next steps also. So we want to support more and more databases. We want to support more and more data sources. So as I talked about, edge-based and the web, some reporting, and integration with edge-based Hive. So I guess that's it. And questions?
Is the data like that is coming from the RDBMS, is it going directly to the mapper machines, or is it first going to the HDFS and then to the mapper machines, or like can we configure where does it go first? Like is it like going to the mapper machines first before the HDFS, or getting copied to the HDFS then the mapper machines?
The mapper machines are the HDFS, right?
Yeah, like they are using the data from the HDFS, right? So like.
So basically, I think what your question is that do you want to
configure it? Like, do we can we configure it in some way that we can process it before it goes into the HDFS?
Yeah, you can. So you can't actually configure it, because what it is as a framework, what it does is that when you run it, it is expected to get data from the database and put it into the HDFS. But if you want because the code is there, what you can do is you can just intercept the mapper and put your own reducers, or you can have a chain mapper if you want. So instead of writing, so what we are doing is that our output is going to the HDFS, but if you want, you can just intercept it and run it in a different manner. I mean, the standard running is obviously it is writing to the HDFS, but there's nothing which is stopping people from intercepting it, plugging in your own reducers, and doing whatever you want, or adding more mappers to it, processing it more.
As you say, like it supports all the RDBMS Hadoop teams, right?
Yeah.
So does it support all the data types as well, or like if we talk about blobs or blob?
It does. I mean, it hasn't actually been tested with blob. I personally haven't tested it with blob, but it does. So when you talk about blob, basically what we're saying is that obviously we will not like the output format to be text, to be a delimited file. So what it does is internally it is converting all the database types to Avro types. So in Avro there is the concept of a byte type. I don't remember what it is, an Avro byte or something.
So Avro just works on JSON, right? It's like simple Java simple public models.
Avro will not run on. Sorry.
Avro is just a JSON subset. We don't have a particular data type in Avro. I think so.
Yeah, Avro is kind of a representation. Like the Avro object is actually represented as a JSON, but they have their own schema limitations. Did I answer your question? Or?
Yeah.
Okay, so I think one thing Sanjay had asked me and I haven't covered in my presentation is the difference between Scoop and HEO, which people haven't actually asked, but I think I can still cover nevertheless. I assume I have sufficient time? So, difference between Scoop and HEO, one thing is that Scoop is structured, I think, more like a tool, whereas HEO is more of a framework. So Scoop is more of, that you run, you get the results, and then you do the processing. And with Hio, what I have tried to do is that, we structure it like a framework and we get more use cases, maybe not necessarily in, one run. So that's the approach. Second thing, so that's like just the approach, the way it is structured. Second thing is that Scoop doesn't support table joins and querying. It is single table, whereas with Hio you have the flexibility to actually have more than one tables. So it's that, in that sense it is more advanced. Scoop is moving faster. It has the backing of a big company. So they see a lot more use cases than I do. So that's and that's like the big reason that I'm here. That I really want to build a community around get people to start using it, start building things around it. Let me know what is not working, and it would be great if we could get some people to just volunteer to contribute to it. Any other questions?
So, isn't it like taking the data, the unstructured data stored on the Hadoop system back to the database, for analysis would create the similar problems that we already have, with analysis over the RDBMS for the big data? Because I'm just trying to understand the reasons for taking the data back to the database.
Okay. So, taking the data back to the database, basically, what we are doing is, the problem that was initially faced is that there was so much data, like petabytes of data, that you just can't store in a database. Like, your database is going to crash. As many whatever big cluster of a MySQL or an Oracle RAD server that you may have, it is not going to be able to process the kind of data that is coming in every day. Just imagine, the kind of images, like the digital images that we are creating, like we are clicking each and every pose of our children, of ourselves against the buildings, and just as an individual, the kind of data that we are generating is like huge. So a traditional database is not able to handle that, but at the same time, that doesn't mean that a traditional database is like, not able to do anything. It still has its advantages. The biggest advantage is the high, its ability to index data, retrieval is very fast. So typically what you have is that you do all the crunching in Hadoop, and then the crushed results, which are much smaller in number, you send it back to the database. So then your website or your front ends or your reporting can then talk to the database directly.
So using Hio, can I plug in a Hadoop job to reduce the data, filter out the data, and then put in the database?
No, the analytics you will have to do by yourself. Hio will help you get the data from the database, and whatever processing you have to do on your own, and then it will help you push the data back, the crushed data back to the database.
So is it similar data that we are sending to the database?
After you've done your processing, your data would actually be, much smaller in sizes. Is that what you?
I think it's a very interesting topic. Let's take it up as a part of the panel discussion. I would really love to hear more about it. We'll take it as part of the panel.
Let's take it as part.
Do you have any performance statistics about Hio?
No, I haven't done a performance benchmarking yet.
So you're saying data is, we are generating a lot of data, that's correct. So, if the data is huge, how can you store it in databases?
I think interesting. I think again, let's leave something for the session panel for the panel discussion as well. And I think we would have many questions, and Sajal might also have something to add over when he does this presentation.
So I think what I'll do is just hand over to Sajal and.
No.
Thank you.
Thank you.